So I'm I'm Max Drotic, and I'll be doing the 1980 Mount St. Helens eruption. There we go. First, I'll go over some data of the eruption. So 57 people were killed, 250 homes, 47 bridges, 15 miles of rail, and 185 miles of highway were destroyed. These were people directly impacted by the eruption, which caused 1 billion in damage. But also the people in this outlined picture here experienced the ash fallout, which were all directly affected by the volcano, despite them being very far away. Oklahoma, very far away from Washington, but they had up to a half-inch of ash. So Mount St. Helens is an active stratovolcano. It's made up of lava rock with ash, pumice, other deposits, and its base layers consist of basalt and andesite. So where Mount St. Helens is in Skamania County, Washington, which is Pacific Northwest region of the United States, 50 miles northeast of Portland and 96 miles away from Seattle. As you can see in the picture on the right here, the right side of the picture is oriented north. And the lava dome you can see here in the central. And the blast, this is an after picture. You can see the blast here really moved down the North Fork of the Toutle River. And then you have Coldwater and Spirit Lake. So when the first initial events started on March 16th, and this was the first sign of activity in over 100 years. And on Sunday, May 18th, 1980 was when the actual eruption occurred. So why did it erupt? Mount St. Helens is on the Pacific Ring of Fire, which is a region of active volcanoes and frequent earthquakes. You have the Juan de Fuca plate and the North American plate, and this is a subduction zone, and the Cascade Range is formed as a result of that. And Mount St. Helens is a very active volcano in the region. So how? The first sign of activity, as I said, was March 16th, a series of small earthquakes, and by March 27th, there was hundreds more. And these small earthquakes and eruptions created a 200 and 250 foot wide crater at the top. You can see the bulge here in the outlined red circle, and up at the top in the inside, that's where the crater would be. So it continued, the crater grew to about 1,300 feet in diameter, which is pretty large, and it continued to grow daily. I believe at times it grew more than others. It picked up its growth, especially towards the end. And the small eruptions continued, and around 10,000 earthquakes had been recorded before the actual eruption took place. And scientists monitored this very closely, and you can see all the news structures lined up here. It's a big event for a lot of people. So the actual eruption occurred at 8:32 a.m. This was triggered by a 5.1 magnitude earthquake, which caused the northern bulge and the summit to slide away in the huge landslide, which was the largest in Earth's recorded history. You can see in the pictures here the progress stages of the landslide. The lateral blast is what followed next, which removed the large cryptodome inside the volcano, exposed the inside, and within 15 minutes, this ash reached a height of over 80,000 feet. That is very high. And as a result of the horizontal blast, the lateral blast, virtually no trees remained in the affected blast region, which was about 230 square miles. And these trees accounted for 4 billion board feet of saleable timber. And a lot of this timber was owned by a Weyerhaeuser, which was a big timber company back in the day up on Mount St. Helens, and still is a very large timber company. The lateral blast did kill many animals. The State Department of Game estimated that nearly 7,000 big game animals perished in the area most affected by the eruption, as well as the small birds and small mammals. However, some of the small rodents were able to survive because they buried deep underground, and they were protected by the heat and movement from the landslide. But also 12 million Chinook and salmon were killed in hatcheries when they were destroyed, and many of them were forced to swim through the hydroelectric generators because their reservoirs were full, and on the hatcheries, when they were destroyed, they were sent downstream. So the vertical eruption continued for 9 hours, which sent the ash column into the troposphere and the stratosphere. And the pyroclastic flows started around 12 o'clock, so about 4 hours after the initial eruption. And the ash cloud spread across the United States in 3 days and circled the Earth in only 15 days. It's a pretty significant event. Here's a video. You can see the ash cloud from space. This is satellite imagery provided by the National Weather Service. Or I should say NOAA. So it had pretty big effects worldwide. That ash column reached several parts of the United States that were very far away from the eruption. Take a minute for the slides to load here. There we go. Here's another demographic picture you can see here. That's one too far. The Cryptodome in the inside here, and the Summit Dome before the eruption, during the eruption, the lateral blasts and the vertical blasts, and then the bulge before and after at the very bottom there. You can see that's quite a big profile difference. So some impacts in the agriculture. Many crops were destroyed. However, some were able to survive, and they were blanketed by a thin covering of ash. And this ash provided beneficial chemical nutrients to the soil, and they saw greater production in many areas of Washington as a result of the precipitation, which was higher than average for that year. So some meteorology in the eruption, what we're here for, the main point. So some immediate impacts nearby. The temperatures cooled about 8 degrees Celsius lower as the sunlight was obscured during the day. This eruption was very early in the morning, so the Earth wasn't really warmed up very much in eastern Washington. And it's said that the temperature remained constant for over 12 hours in Yakima and other parts of eastern Washington. Now, as we move farther away, Idaho, Montana, and Wyoming experienced warming, which is the opposite, as the ash cloud reached them at nighttime, which reduced infrared cooling by insulating the inside by the cities, and warmed up over time, which is interesting to note as it caused cooling and both warming as an immediate impact. And this deceased over time as it drifted and thinned out. Witnesses also observed lightning in the ash column, which the way that a volcano produces lightning isn't really too much different. In the ash cloud, you have the rock and ash, which creates your charge separation instead of the ice as it would in a normal thunderstorm. And it is also said that most major eruptions produce lightning, which makes sense if you have a lot of a static friction and moving air. So some long-term impacts. Volcanoes do have a potential to have a long-term impact on climate change. Mount St. Helens, however, it didn't have a large effect. I believe it would only reduce cooling by an estimated 0.1 degrees Celsius decrease, which is pretty much nothing. And this main cause for cooling is from sulfur dioxide. And the main cause for warming is carbon dioxide. So volcanoes can release different amounts of each into the atmosphere. So data from NASA showed that the El Chichon eruption, which was in Mexico of 1982, produced 40 times as much sulfur dioxide as Mount St. Helens. So this kind of proves that Mount St. Helens eruption was a little bit weak when it came to sulfur dioxide, which is why it did not have a large-term effect on climate change. It only had short-term effects from the ash column. So 70% of the glacier's mass was decreased during the eruption. It was in May, so still quite a considerable snowpack on Mount St. Helens. Fortunately, by 2004, the glacier had grown into a horseshoe-shaped feature that wrapped around the lava dome, and in 2006, it approved for the name Crater Glacier. Vancouver, Vancouver, this is it, was a quote by David Johnson, who was a USGS volcanologist, and unfortunately he was killed at a station Coldwater 2 as a result of the eruption. And for all the people lost, they formed the National Volcanic Monument, the Johnson Ridge Observatory, named after David Johnston. For all of this affected, $1 billion in economic damage, But the observatory was also made to teach youth and other people about the eruption. And it's a great learning center. I was there as a kid, and it's very informative, which is good to pass on that information. Thank you for watching. Virtual presentation, a little bit different. These are my sources used, APA format. Most of these are USGS